let us see how we can locate the centroid of a plane area. We know the centroids of regular shapes. Say for example, if it is a square, its geometrical center will be the centroid, and if it is a circle, the centroid will be its center itself. But if it is a complex area made of different standard shapes, say an area made of two rectangles, there will be a T-shaped plane area. Let us see how to find the centroid of such a shape. So a T shape is made of two rectangles like this. This is the T. It's a plane area having some area and other dimensions. For this, the dimensions are 20, all are in mm. Then this distance is 300 mm. This is again 20, and this distance is 200 mm. All distances are in mm. Now we need to find the centroid of this complex area. Then how to find out the centroid of this complex area? For that, first of all, we will draw the axis, reference axis for the shape. So these are the reference axes, X, Y and O. Then we will divide this shape into two standard shapes, say two rectangles. Let this be first rectangle, let this be second rectangle. Now we will find the centroid of each of these rectangles and the distance of that centroid from the reference axis we have already drawn, that is from X and Y. So I will draw this rectangle separately with the same reference axis. Okay, so it will be like this. This will be the first one. Okay, and we know the distances. This distance is 20 and this height is 300. Okay, and what will be this distance? This distance is this distance, that means it will be 200 minus 20 divided by 2. That is, up to here it will be 200. So this distance will be 90. 200 minus 20 divided by 2. That means this is the total distance up to here. We minus this area and divided by 2 will be, or if you minus this distance, it will be the sum of this distance plus this distance, that is this distance plus this distance. Therefore this distance will be 90. 180 by 2, 90. Okay, then what will be the centroid of this rectangle? Its own centroid will be its geometrical center, say G1, and we need the distance of the centroid from the reference axis x and y. Okay. Similarly, for the second rectangle, we have this is the second rectangle shape. So its centroid, its own centroid will be like this, say G2. Okay, so how to find out the centroid of the distance, centroidal distance from this reference axis? So what will be this distance? This distance will be, this is 300, this we know it is 300, and this is 20, therefore this distance will be 300 plus 20 by 2, that is 300 plus 10, that is 310. That will be the distance of this centroid, and it is easy. This distance, that is this distance will be, how much it will be? 200 divided by 2 equal to 100 mm. So this will be the centroids. Now its centroid is 300 by 2 equal to 150. So we got all the distances. Now we can find out the centroids. So to find out the centroid, we have the equation, the x coordinate of the centroid, x bar equal to a1 x1 plus a2 x2 plus etc. plus an xn divided by a1 plus a2 plus etc. plus an. That is equation. Similarly, y bar equal to a1 y1 plus a2 y2 plus etc. plus an yn divided by a1 plus a2 plus etc. plus an. These are the equations for x bar and y bar. Now, how to find out x bar? So this a1 means area of the first shape. Here a1 is area of this vertical rectangle, and a2 is the area of the horizontal rectangle, that is 20 by 200. Here it is 20 by 300. That is the area a1, area a2. For this, area is a1, this area is a2. The rectangles area a1 and a2. The x1 is the distance of centroid of the first rectangle from y-axis. So this is x1. Similarly, this is y1. That means distance of centroid of this first rectangle from x-axis, perpendicular distance. So this is x1 and this is y1. x1 and y1. And what will be x2? This will be x2. That is distance of centroid of second rectangle from y-axis, x2. And y2 will be this 310. So this is y2. This is y2. Say this distance. y2. Okay. Then let us calculate the x bar equal to a1 is how much? 20 by 300. That is 6000. So 20 into 300 plus x1 is, how much is x1? x1 is equal to 90 plus 10, 100 plus, this is the area, into 100 plus a2 is 20 into 200, that is 20 into 200 into x2. x2 is 100. Okay, so we have only two areas, therefore we have only two terms here, and divided by a1 plus a2, that is 20 into 300 plus 20 into 200. Okay, so this will give you x bar. X bar equal to, we will get it as 100, because when you calculate this, you will get it as 100 mm. So this is how we need to find out x bar. In this case, x bar is same as the centroid of x distance, that is 100. For both the areas, we have 100 as the centroidal distance from y-axis. Therefore, even if you calculate this, you will get it as 100 mm. Okay, then y bar. How to find y bar? Y bar is equal to this 6000 into y1. What is y1? y1 is 150 plus this is 4000 mm square into y2. y2 is 310 divided by 6000 plus 4000. When you calculate this, you will get y bar equal to 240 mm. Okay, so this is the centroidal distances, that is distance from the reference axis. So the centroid will be 214. It will be around x bar will be like this, and it will be around here. So this is 214 and this is 100.